Okay. This is the heterocephalous glaber, otherwise known as the naked mole rat. I was going to call it NMR, but I'm very bad at organic chemistry. Here we have a naked rat and a mole, and these are not the same thing as a naked mole rat. But over here is the blind mole rat. We'll be talking about that towards the end of the presentation because they do have some similarities that we do want to go over as well. So first we want to talk about the life of the heterocephalous glaber and exactly why it needs HMW-HA. Here we have, this is basically their environment. You have the burrows here and you have the different types of naked mole rats. You have the workers, you have the naked mole rats that are allowed to mate with the queen, and of course the queen, of course. And the queen, as soon as she becomes queen, all of the other naked mole rats that are female become sterile. So you have the sweepers, the diggers, you have the volcanoers, because they throw it above. And then you have the nesting chamber here, and you have the root vegetables. The root vegetables are, compared to them, are extremely big because they're only about 70 centimeters big. And one root vegetable can feed a whole colony for 2 weeks, and a whole colony has about 70 pups in its entirety. And throughout their lifetime, a queen will lay about 90 pups. So try to imagine one pregnancy and doing that 90 different times.
So they're literally about that big.
Yeah. And then here, it's just showing you about their usual hierarchy. Even though they aren't really that different, just because they're able to mate with the queen, they literally are above the other ones. Inside these tunnels, they go above and beyond. That's the reason they have loose skin, so they're able to go over one each other pretty easily. So then you have the one on top here, and that's the one that's able to mate with the queen. And you have the workers who will be either male or female. And then you have what we had on the previous slide before, so I don't have to go over that. And then we have the naked mole rat itself. Luckily for the naked mole rat, it has the teeth outside of its mouth. So when it's burrowing for food and for other things, it doesn't have to ingest all the soil and all the other nefarious objects that it might ingest. Otherwise, its life would really suck. So then, when the scientists were experimenting on a naked mole rat, they were experimenting by introducing their cells to a bunch of different diseases, and every time they did their experiments, there was this weird viscous liquid inside of it. They didn't know what to call it, so for now they just call it the goo. That's why we have this scientist here holding a piece of green stuff. Later they call it HMW-HA, and this is what it actually looks like, not like the slime from before. So what is HMW-HA? That's the question that we all want the answer to. HMW-HA is mainly this polysaccharide sugar, and it has N-1. This is the condensed version, because it can be spread out as much as possible for whichever organism needs it. And in this case, it's pretty small, just for aesthetics. And here we have the cell. The HMW-HA is located in the extracellular matrix of the cell, so it's normally on the outside, and it coats the outside of the cell for a very specific reason, which we'll go into later. And you don't have to read all this, that's just extra. So then, how is HMW-HA produced? We have hyaluronic acid synthase 1, 2, and 3. And it's present in all other organisms, and it's not just specific to the naked mole rat, but for the naked mole rat, they have HAS2, which is working overtime, and normal organisms only have HAS1, 2, and 3 working at a normal pace. And then here we have UDP, which is uracil phosphate, there we go. And we have glucuronic acid, and we have UDP with N-acetylglucosamine, and added to the, we have an HA molecule here, and this is the HAS2 synthase, and it's making it as long as possible. So they're adding on the glucuronic acid and the N-acetylglucosamine, making it as long as possible, and it's being extruded from the ABC transporter into the extracellular matrix, which is the ECM, which you see here. So then we want to talk about the benefits. How does HMW-HA actually help the naked mole rat? So from this picture here, it's mainly it helps the naked mole rat outlive their rodent counterparts by about tenfold. The normal rodent can live about 3 to 4 years, and naked mole rat can live roughly 40 to 30 years. So they're outliving most of us right now. Also, you can see different types of cancer. You have oral cancer, neck cancer, all this other stuff, and it doesn't apply to the naked mole rat at all. They have no chance of contracting tumorigenesis, which we're also going to go into as well. And lastly, they have contact inhibition, which we'll also get into, but we're just going to call it a superpower for now. So how does HMW-HA prevent cancer? So then we have these two proteins here. We have P16 and P27. P16 is a tumor suppressant, and P27 is an enzyme inhibitor, which activates the CDK CDK148 or the CDK D CDK148 to control the G1 phase, which also is going to be important, which we're also going to talk about later. So then we have the G1 phase here, and the difference between the naked mole rat and the actual other organism is that P16 and P27 are coupled, which means whenever P27 or P16 is activated, they activate together rather than working alone. And when HMW-HA is working simultaneously with P16 and P27, that allows them to be decoupled and to work together. And when you have P27 and P16 working together, you have P27 controlling the G1 phase, making sure there is no extra damaged cells, because the normal motif of cancer is that it proliferates damaged cells. And it extends it to a certain extent, so you have more healthy cells which come out of the G1 phase rather than the damaged cells. And if it does manage to actually get out of the G1 phase, the P16 acts as a tumor suppressant to make sure that it still does not get out of there. And also, we have CD44, which comes in contact with the contact inhibition, which we just mentioned before. Contact inhibition is basically saying each tumor has the characteristic of a lot of CD44 receptors, and this allows them to adhere to other tumor cells and also other healthy cells, so they can infect and also make other tumor cells. Because HMW-HA acts like an agonist, it reduces the bioavailability of these CD44 receptors on the healthy cells, so the tumors can't bind to the other cells. So when it tries, it just lobs off and then just gets extruded through the waste. So when it's a contact inhibition, it literally means as it's trying to bind to these other receptors, it can. And one of the amazing things about HMW-HA, it also binds to the tumor itself. So also the CD44 receptors on the tumor, so other tumors can't glob onto each other. So it's like a fungi which wants to bud off, but it continuously buds off until there is no more. So with this three-pronged attack, it has P16 and P27 decoupled and contact inhibition all working together. This is why it's almost negligible why they can't even get cancer, or better said, tumorigenesis. And this is just explaining contact inhibition, and they literally just can't touch other cells. So then we want to talk about how does HMW-HA help with aging. For now, no one knows. We only have a bunch of theories because, again, if we knew how aging actually worked and how it went forward, then we'd be able to control it ourselves, but we only can assume how it works. So there's two prominent theories which I want to go over, which I feel is the most important. The first one is that during their lifetime, they live most of their life underground, and they have a severe lack of oxygen. And when you have a severe lack of oxygen, there's a high chance of oxidative damage. So then we assume that all the cells, the proteasomes that allow to clean up the cell, which make sure that it proliferates safely and for a long period of time, is actually kept intact. So then we ask the question, why isn't this happening in the naked mole rat? this isn't happening in the naked mole rat because they don't know how exactly. Well, I read about 10 papers. They keep saying it should be undergoing oxidative damage, but it's not. So the link that they normally see between oxidative damage and oxidative damaged cells is not being demonstrated inside the naked mole rat. They're assuming that the HMW-HA is either giving them some kind of protection from the oxidative damage, or it's just they just don't get it for some reason, which is, again, they still don't know. Because again, the body's like a universe, and we don't know what can be activated and what. And that's just it doesn't work on that. And the second theory. HMW-HA, as we mentioned before, has P16 and P27 decoupled. So when P27 is decoupled, it allows the G1 phase to work at its normal pace. So when it detects a damaged cell, it in fact increases the G1 phase. And when it does this, it gives the more healthy cells time to proliferate, which I mentioned before. And when this happens, they believe that the mitotic cell division is actually longer. So let's say it takes 20 seconds for us, for them it would probably take about an hour to actually separate. So since they live at in a very sedimentary lifestyle, that they don't have to burn as much ATP, so they can have their life cycles be as slow as they actually need to be. Which again, it does have some downfalls to this theory, because they're only assuming how the mitotic cell division works, because again, we're only working on theories, hearsay, and what we read from other articles, which may or may not be correct. Okay. Everything I'm saying sounds good, but we need proof. We want to make sure that this works. So we want to see the proof in the pudding, and we want to see the money. So then they test this theory by using the gene knockout method on HAS2. And the gene knockout method is really simple. If you want to know what a specific sugar, in this case we have polysaccharide sugar, protein or whatever, you knock out the protein or gene that creates that protein or polysaccharide sugar. And here we have naked mole rat with HA, hyaluronic acid, and without, plus or minus. And the guinea pig and the mouse, they show very little signs of it, because HMW-HA is staying with acrylic stain, which stains blue. So you can see here in the heart, it has blue staining here, as well as the skin we have as well. So then, just by this, we can immediately tell that it does help with cancer a lot, because this is the control, where you see that it still has HMW-HA still intact, and HAS2 is still intact as well. And this is where they overexpress HYAL2, which degrades HAS2. So there was two methods that they could have done this, but the one they used was a lot easier. HYAL2, when overexpressed, it actually breaks down and degrades HAS2, which would also stop HMW-HA from being produced, or overproduced in this case. And from where we have HYAL2 being overexpressed, we have a tumor forming and keep growing bigger as time goes on. And since mice don't have that much HMW-HA, of course they would have tumors. And then we have the same shRNA that's then knocking out the HAS2, or hyaluronic acid synthase 2. So then, I said a lot. I just want to make sure that we go over everything that we just talked about. So in summation, naked mole rats live in huge social hierarchies. They are immune to cancer. They outlive their rodent counterparts. They have the ability of contact inhibition. They have such cool superpowers. How the goo is made and how it actually works, and what it's like for a naked mole rat without HMW-HA, which is getting cancer and also decreased life. Let me say it this way, would decrease in essence. And for future studies, they're trying to make, or better, they're trying to synthesize HMW-HA in a laboratory so we can put it into other organisms, see how they work. I mentioned before that every single organism and every single body is like a universe. If we take out one thing and put in another thing, we don't know how that's going to interact with something else, and it's just going to throw the whole body out of whack. So we can't just randomly throw it into a different organism and hope for the best. And also, same with testing HMW-HA in vitro and in vivo. They want to test it on cells first to make sure that there are no cancerous cells forming in the plate. And after that, then they would inject it into a living organism just to be sure it's actually working the way it says it does. Acknowledgements. I want to thank Professor Cadet for being my mentor and cutting out a good bunch of the terrible jokes I had in there as well. Professor Neto for being here, and for all you guys for sitting here listening to all this. And here are my references, and does anybody have any questions?